Welcome to PMdistilled. In this video, we will be discussing activity sequencing in detail. We started with high-level requirements. Then we moved on to product breakdown structure, followed by work breakdown structure. And we said the lowest level in the work breakdown structure is the work package. The next step was decomposing those work packages into activities, and the subsequent or the next logical step after activity definition is the activity sequencing. So the work packages gets decomposed into activities and we get the activity list, and the next is activity sequencing. The key thing to be remembered here or to be understood here is the 4 types of activity dependencies. The first one and the most common one is the finish to start dependencies. We call it as FS. That means one activity must get over in order to start the subsequent activity. For example, if it is your PMP certification, one need to complete the 35 contact hours, the training program, before you apply for the exam. Or if it is a building project, unless and until the foundation is done, we cannot start the substructure followed by the superstructure. And in a software project, if you are following a classical waterfall model, unless and until the requirements are frozen, I will not be able to start with the design. So these are examples for finish to start dependencies. Then we have start to start dependency. That means something has to start for me to start something else. In software, when the testing starts, I can start the defect fixing. As soon as the testing starts, defects will surface. Then parallelly, I can start defect fixing. In a construction project, once the tiling work is completed, or when the tiling work is almost 60% completed, maybe I can start carpeting. So something has to start for me to start something else. In software, when the design is almost 50 or 60% completed, I can start with the coding part of it or the construction part of it. Then we have finish to finish dependencies. That means something has to finish for me to finish something else. In a building project, when the tiling work is almost 80% completed, I may start the carpeting. At the same time, I will not be able to complete the carpeting unless and until the tiling work is completed. Similarly, in software, I may start testing, I may start defect fixing or bug fixing when the testing starts. At the same time, I will not be able to complete bug fixing unless and until the testing is completed. That means something has to finish for me to finish something else. So here generally people ask this question, can we have both start to start and finish to finish dependency at the same time? That is quite possible. For example, I can start testing, I can start defect fixing as soon as testing starts. And I will not be able to complete defect fixing unless and until testing gets over. Then we have a very freak or very rarely occurring dependency, that is start to finish. Something has to start for me to finish something else. This is very, very, very rare. An example for this could be when the main power supply comes, maybe I can stop the generator. So that is an example for start to finish. So in at least 80% of the time, the dependencies will fall into finish to start, then followed by start to start, and finish to finish. So these are the four types of dependencies among tasks. So when we do activity sequencing, we need to understand the dependencies between tasks and then sequence it. In IT project, this can be fairly easy, whereas in a construction project, this can be very complex because of multiple disciplines involved. Because unless and until the civil work is completed, I may not be able to install the MEP stuff. There are a lot of interdisciplinary dependencies which must be taken care of while sequencing activities in a construction project. Whereas in a IT project, this is fairly simple. Then another point we need to consider is, okay, activity sequencing. There are two ways of doing it. We use activity on arrow diagrams, which is also known as arrow diagramming method or ADM. In arrow diagramming method, activities are represented by arrows and connected at the nodes. Then we have activity on node diagrams. That means activities are within the nodes and connected by arrows. Activity on arrow diagram or arrow diagramming method can be used for very simple projects where the number of activities are very less. And sometimes in activity on arrow, we use dotted lines, which is known as a dummy activity, to show dependencies between tasks. Dummy activities doesn't consume any resources. It is used just to show the dependencies between tasks. That is with respect to activity on arrow diagram. If I have to draw a schedule for preparation of a course material, then activity on arrow will work. Or if I have to draw a schedule for organizing a get-together, an activity on arrow will work. But when the number of activities are very high, it becomes very difficult. And another point about activity on arrow is it can show only finish to start dependency. Whereas activity on node diagrams, they can show all the four types of dependencies, like the finish to start, finish to finish, start to start, and the start to finish. Hence, it is very, very widely used, especially tools like MS Project or Primavera, etc. The underlying logic is the activity on node diagram. Irrespective of whether we are using an activity on arrow diagram or the activity on node diagram, the longest path in the network diagram, we call it as the critical path. I'll repeat once again. The longest path in the network diagram, we call it as the critical path. So it is also known as sometimes we say it is the shortest possible time in which we can complete the project. So if you take the project network diagram, there can be multiple paths going through it of different durations. And if we have to identify the longest path in the network, that is the critical path. Activities on the critical path, they cannot slip. If they slip by 1 day, the project will slip. Whereas activities on the non-critical paths, even if they slip within their float, the project will not slip. Then we have another, we discussed about uh, critical path, non-critical path, and sometimes we get paths which are very close to the critical path. For example, let us say the critical path is 200 days, and I have another path which is 199 days. So, for all practical purposes, the technical reasons, it is not critical path because it is not the longest path. So, such paths which are very close to the critical path, we call them as the near critical paths. So, in order to be successful as project managers, we should always know the critical path, the near critical path, and the paths which has a float. So this will help us to monitor and control activities, and the knowledge of critical path, near critical paths, and the non-critical paths will help us to optimize the resource allocation among these paths. So another question is, can a project have multiple critical paths? That is also quite possible, because you have one path is 100, another path is 99, another path is 80, then we have one more path which is 100. So there are two paths with 100 duration, and that is the maximum duration. So in this case, or in this scenario, we have more than one critical path. So it is important to monitor and control the critical paths and the near critical paths on a regular basis in order to avoid slippages. We'll be explaining these things further in the associated text and the upcoming classes as well. So without understanding critical path, near critical path, and multiple critical paths, and float, slack, negative float, etc., please don't move to the subsequent lessons. If you have not understood things, watch this video once again, go through the material, and during the live class, we will discuss more about it. Come prepared with your questions. I'll answer all your questions in the live class. Thank you very much.